Okay, we're going to look at acceleration again. Remember, acceleration is a rate of change of velocity and it's a vector. This time we're going to be looking at multi-step problems. This time it might take 2 or 3 steps in order for you to solve the problem. And this is where our problem-solving technique becomes extremely important. So make sure you follow it. Otherwise, you will find yourself in trouble. We're going to use a standard problem-solving technique where we underline key points, we make a list of our variables, we write down the formula you're using. You can get that from the data sheet. We substitute the values to solve, remember units, and we always ask ourselves if it's a scalar or a vector, because if it's a vector, it needs a direction. This is a fairly typical example where you'll have to do multiple steps in order to find the final answer to the question, which is a displacement question. Sometimes they will provide you with the steps that you need to follow, but a lot of the times they won't. So it's important that you can identify what you're doing. So this is where our problem-solving technique is really, really important. And if you come to me for help and you haven't followed it, I'm going to send you back to do it again. So a car is accelerating at 3 meters per second south. So the acceleration is 3 meters per second south for 4 seconds. If the car was initially traveling at 12 meters per second, so that's the initial velocity is 12 meters per second, calculate the final velocity. So the final velocity is v. So we're going to do that. V equals u plus at. Our initial velocity was 12. Our acceleration was 3, and it went for 4 seconds. So this comes out to 24 meters per second south. So we've done part A. Part B, an average velocity. Now at the moment we have a final velocity and we have an initial velocity, and we need to find the average velocity. So an average velocity can be calculated by doing an average of the initial plus the final divided by 2. So the initial velocity was 12, the final velocity was 24, 12 plus 24 is 36, divided by 2, and it comes out to 18 meters per second south. Now the next step is we need to find the displacement. So the displacement, remember, can be calculated from the average velocity. So we know the average velocity is now 18. The displacement we don't know, but the time is 4. So the displacement is equal to 18 times 4, which comes out to be 72 meters. Now remember, displacement is a vector, so you must provide a direction, which is south. Now let's look at a second example. Our car is decelerating at 4 meters per second south. This means they are slowing down. So if their acceleration is 4 meters per second south, that means they're actually doing -4 meters per second north. Remember, we need them in the same dimension until it comes to rest. So the final velocity is 0 meters per second. If the car was initially traveling at 25 meters per second north, calculate the time taken. Okay, so we're going to find the time. Now we know acceleration is equal to v take u over time. So we've got the acceleration is -4. The final velocity is 0. We're going to subtract the initial, which is 25, divided by time. So rearranging, this would become time is equal to -25 divided by -4. And this comes out to be 6.25 seconds. Now it's really important here that you don't get a negative time, because negative time is not allowed. Now the next step, it says calculate the stopping distance. Well, in order to do a displacement or a distance, then you need an average velocity. So because we want to find a displacement, we need to have the average velocity, which we don't have. Notice it's missed out one of the steps. So you have to work that out yourself. So we know that V average is U plus V divided by 2. So the initial velocity was 25. Add 0, divide by 2. And this comes out to 12.5 meters per second, which will be north. Now the final step is to find the displacement. So we know that V average is equal to a displacement over time. So 12.5 equals displacement over the time of 6.25 seconds, which we calculated early. So displacement is equal to 12.5 times 6.25, and this comes out to be 78.13 meters. Now remember, because we've been given directions, this is a displacement, so it'll be 78.13 meters north. Now let's look at our final example. In this example, a stone is dropped from the top of a well. So here's our stone. It's dropped down a well all the way to the bottom. If the acceleration due to gravity is 9.8 meters per second and it takes time is 4 seconds to hit the bottom, calculate the velocity just before it hits. So before you let it go, the initial velocity must be equal to 0. So what we don't know is the final velocity. So we go V equals U plus AT. The initial velocity was 0 plus 9.8 times 4. And this comes out to be 39.2 meters per second. Now, in order to find the depth of the well, and by the way, that's down, in order to find the depth of the well, then we need to know the average velocity. So once again, we're going to have to find an average velocity. So V average equals U plus V divided by 2. Our initial was 0 plus 39.2 divided by 2, and that comes out to 19.6 meters per second. Down. Now that we've got our average velocity, we can find the displacement. So V average equals displacement on time. So 19.6 is equal to the displacement divided by 4. So the displacement equals 19.6 times 4 by rearranging, and this comes out to be 78.4 meters, and the direction is down. Try some yourself. The harder problems are in worksheet number 3 of the acceleration group, and good luck.